Let's go through Leaker 1312 minimal insertion steps to make a string palindrome. For this question, it gives us a string S and ask the minimal number of character to insert to the string to make this string as a palindrome. The first example, ZZAZZ itself, it is already a palindrome. So we don't need to insert anything. And the second example, MBABM, we can insert an B and an D right here. So we need at least insert 2 characters, and also lead code. We need insert at least 5 characters. So for this question, we see the second. Let's look at the second example. We need insert an D and an B here, right? So the things that we look at actually the M A M is already palindrome, right? M A M is palindrome, but there is some of the characters like a B and a D, they are not. So what we thinking about is that we just need to insert those kind of characters which is not which is outside of the palindrome. So what we think about is that we can find the longest palindrome subsequences, and the rest is the one which we cannot find a corresponding match. We need to insert. So for example, if we have a string, the longest palindrome subsequence is, for example, is some kind of this character, and this character, right? This character, for example, this, we use this as longest palindrome. So what we need to do is that for the rest part, in its from the left, right, and to the right, we find in the corresponding position, insert a character, right? So this question is convert to the length of the string minus the longest palindrome subsequences, right? So if we know these conversions, how can we get the longest palindrome subsequence of an string, right? Actually, we can use some kind of DP dynamic programming, right? The things that we know for this, for example, this kind of string, right? And we know for every character, we use DPI J. Which means the longest palindrome subsequences from I to J, right? In this kind of range, what is the longest palindrome subsequences? So for example, this is I and J. So what we do is that we can expand it to I minus 1 and J plus 1, right? So if the character I minus 1 and J plus 1, they are equal, then we'll see the dp I minus 1 J plus 1 will be equals dp I J plus 2, right? If they are not equal, then we'll see the longest palindrome will be max this part and this part, right? So what is the initial condition is that we'll say dp I, right? The length is 1, right? And as for dp I and I minus 1, I plus 1, right? Because we need to convert two positions, I and I plus 1, we need trying to see whether I and I plus 1 are equal or not. If they are equal, then that is 2. Otherwise, it is 1, right? And actually, we'll find this is actually can be coming from dpi and I minus 1 equals to 0. If we set dpi and I minus 1 to 0, we can also have the same conversion to dpi and I plus 1, right? Whether it is add 2 or add 1, right? So let's begin to write code for this. Let's convert this character as array, which array, and so have the array data length. So what we have is int dp equals new dp n and n, right? So dp I j that represent in the range I and j the longest parent length, right? So as we talk about, we can initialize this one. Insert I for int I equals to 0, I smaller than a, I plus plus bp I equals to 1, right? And also we can also write something like for int I equals to 0, I smaller than n plus 1, I plus plus dpi, and I plus 1 equals, so character array I equals array I plus 1 or not, right? These are plus, then otherwise these 1, right? So actually, we'll see if we set dpi, if we don't initialize anything, for example, the default value dpi and I minus 1 equals 0, right? So this will be the same condition as we have the dp conversions. So if we let's write the dp conversions, and in that case we can get rid of these kind of initializations. We can go back to this. Let's leave this right now. So what we do is that we have for int now this one is length 1, right, and then length 2, right? So we have int length equals to 3, length smaller equal to n, length plus plus, right? And let's say for int I equals to 0, I smaller than I say I plus length smaller equal to n, I plus plus, right? So I say int j equals I plus length minus 1. Okay. So I say if array I equals array j, we'll have dp I j equals dp I plus 1 j minus 1 plus 2, right? Else, let's say dp I j equals max dp I plus 1 j and dp I j minus 1, right? So in the end, we just need to return dp here, the dp ig, right? So what we need to return is actually the n minus dp 0 and n minus 1, right? Because this is the longest subsequences. So what we need to insert is those kind of numbers which cannot form the to participate to form the longest subsequences, right? And if we look at this kind of length equals 3, right? So actually, you see this one also have the same condition as this, right? And dpi and I minus 1 equals to 0. This is this also represent this. So we can put this kind of initializations, for example, to be in the same as here, right? So that is that we same as we initialize I and I minus 1 equals to 0. Okay, so in this case, we don't need this kind of condition. This is a minus 1. Okay. The time complexity is n multiplied by n. Space complexity is also n multiplied by n. Convert this to Python code. So we'll have n equals length array length s, and we have dp equals so this is n multiple by n, right? So that is 4 underscore in range. Right. So we initialize for I in range n, dp I equals 1, right? So what we do is that then we need to for length equals in range from 2, right? Because we already have the length 1 and length minus 1, right? To this, right? And for I in range n minus length plus 1, right? We'll have j equals I plus length minus 1. Okay. So we'll say if array I equals array j, then we'll have dp I j equals dp I plus 1 j minus 1 plus 2, right? Else we will get its maximum of I plus 1 and j minus 1. dp I j equals max dp I plus 1 j dp I j minus 1, right? In the end, we return n minus dp 0, n minus 1. Array is not defined. This is not array, it's actually S, right? S.